Okay, we're going to talk about annuities. An annuity is a fixed sum of money that people save up for retirement, and it's the reverse of a personal loan. So it's payable installments over the course of a recipient's lifetime. So basically, it's a sequence of equal payments that are made at equal time intervals over the course of time. So, and we'll talk about more of that in a minute. So we're going to be using our TI-84 calculator or TI-83 calculator, and the thing we're going to be using is a TVM solver. So what you're going to be doing is you're going to be pressing apps. So if I press apps, that's the purplish button right here, apps, and then I'm going to press go where it says finance. I hit enter, and then TVM solver, I'm going to press enter, and that takes me to this screen here. And on this screen, there's these different things that they're going to ask you for. They're going to ask, N stands for the number of total payments, which is the number of years times the number of years you're doing it, and the number of payments. So if it's monthly, this will be the years times 12. If it's just annually, then it's just going to be the years. Okay, you've got your interest rate they're going to give you. Present value, that's how much it's worth at the moment you start doing it. Future value is the value at the end. Payment, this is how much you're going to pay each time. When you pay things, the value is going to be negative. And payments per year. So, and we'll be using different values for this and compound per year. Okay, so when it's an annuity, you're going to be highlighting begin, and if it's anything else, you're going to hit end. Okay, you might want to hit pause and copy this down. Okay, so Anton wants to retire with a monthly income of $2,500. His retirement account earns 2.2% annually, and it's compounded quarterly. If he retires at an age of 67 and lives to be 90, how much money should be in the retirement account when he retires? Okay, so the first thing I'm going to do is we're going to figure out the end value here. So so we know that we're going to be doing this so between ages 67 and 90, it's going to be 23 years, right? And he wants monthly. He wants a monthly income, right? So 23 times 12 is going to be 276 months. Okay, so we're going to have 23 times 12, and that's going to be 276 payments or times that it's going to be compounded. Okay, so let's go through the process again. You hit apps, you hit enter for and then TVM solver, and then we're here. So we're going to change this value here to 276. Okay, the interest is 2.2. So I'm going to put 2.2. You're not going to write a decimal. Do not write 0.022. That is not correct. Okay, so you have to put 2.2. Okay, so the present value is going to, this is what we're trying to figure out. Okay. So how much money should be in the retirement account when he retires? That's what we're going to figure out. PMT is the payment that you're going to be making. So the payment that the monthly income that we want is $2,500. Okay. At the time of when the person becomes 90 years old, the future value here is going to be 0. Okay, because at age 90, you have spent all your money. Okay, age 90, you've spent everything. So compounded quarterly. So when things are compounded quarterly, this one with the C, that stands for compounding. Okay. Now, you want to get your payments made annually, so this is going to be 12 because you want monthly payments. Okay, so let's put all this information in, and then when we're all done, we're going to hit alpha and enter to get our answer. Okay, so let's do this on the calculator now. Okay, so I've got 276. I'm going to change this to 2.2. We don't know this one. PMT is going to be, oh, I'm going to put in -2500. Because this is a payment, we're going to put a negative. Okay. Negative. Okay. And then futures are at 0, 12, and then it's compounded quarterly. And now I'm going to go up to PV here. I'm going to hit alpha, enter, and I'm going to get my answer here. So after I've hit alpha and enter, then my answer is 541,345. So in order to get a payment of this amount after 23 years, I have to pay, I have to have, this is what I'm going to need when I retire. Okay, let's do another one. Okay, you may want to hit pause and copy this down. Okay, I invest money in an annuity that appreciates at a nominal interest rate at 7.1%, compounded quarterly. I start with $30,000 and make monthly payments at $650 each month. How much will I earn after 20 years? Okay, so this is going to be 20 times 12, so 240. And the interest is 7.1%. So 7.1. We started off with $30,000. So we have an initial value here of $30,000. Okay, present value. So present value is what we start off with. Okay, in the previous one we started off with nothing. Okay, and we're going to be making monthly payments at $650. So this is going to be negative, this is negative, this is what we're putting in, and we're going to find out what our future value is going to be. And you want the payments, they're going to be monthly, so we're going to put a 12 here, and then it's going to be compounded quarterly, so we have to put a 4 there. All right, let's put this in the calculator and see what we get. So, oops, here we go. So 20 times 12, 240, okay, this is 7.1. PV is negative 30,000. PMT is negative 650. We don't know the future value yet, 12 and 4. So to figure this out, I have to hit alpha, enter. And we get 463,590.88. Okay, and so this is how much I will have after 20 years. Okay, so how much did we pay in total? Okay, so we started off with this amount, right? So we started off with $30,000, and then for 240 periods, we kept depositing $650, right? So multiply those together and add this. Plus 240 times 650. And we get 186,000. And but it's worth 463,590. Let's forget about the decimal. So how much did we make? So we have this value minus how much we paid, and we get 277,590. And this is how much we made. Okay, you might want to hit pause and replay if you're a little confused. Let's do one more example. Okay, at age 30, you deposit $150 at the end of each month into an IRA that pays 4% interest compounded monthly. At age 65, what will the value of the annuity be? How much interest will you earn? Okay, so the first thing I'm going to do is at age 30 you start, age 65 you stop. So so we know that the difference between 65 minus 30 is going to give me 35 years, right? So we're going to have 35, and it's going to be monthly, so times 12, which is 420. Okay, my interest rate is at 4%. PV, present value, so we're starting off with nothing, so that's going to be 0. Payment, you're going to be depositing 150, so I'm going to put minus 150. The future value, that's what we want to figure out. How much will the value of the annuity be? Okay, so we'll figure that out in a minute. And everything's happening monthly. It's compounded monthly. You're getting money back monthly. So this is going to be 12 and a 12. Okay, so let's put this in the calculator and give it a shot. Okay, so 420. Interest rate is 4. PV is 0. The payment is 150. Future value we don't know. That's 12. This is 12 because it's compounded monthly. And I go back to FV and I hit alpha, enter. And you get 137,059.64. Okay, so at age 65, the value of the annuity will be this. Okay, now question 2 says how much interest will we have earned? So in order to figure out the interest, first we have to figure out how much did we deposit. So how much did we deposit? We did. We were depositing 150 each month, and we did it for 35 years, and we did it 12 times each month. So this is how much we deposited, 35 years, 12 months, and you multiply those all together, and you get $63,000. So the amount earned is the value of the annuity minus the 63,000, and that gives me $74,059. So this is the amount of earned by doing this annuity. And I hope this helps, and please watch the additional videos that I have attached in the link.